Bright Tuty. Every student matters.
Hello students, this is the 11th chapter of your syllabus and the name of this chapter is Force and Pressure. In this chapter basically you are going to understand force, what force is, what kinds of forces are there, and what is pressure and how it is exerted on us, right? These are the two topics of this chapter. We will be studying more about force. We have a different chapter for pressure and friction. So in this chapter we are going to study more and more about force. Let us start. Students, in this chapter we are going to cover some important questions such as how do objects move? How can we decide whether an object is moving faster than the other? Right? So, for example, you are traveling on a road and you see that one car overtakes another car. So you understand that this car is moving faster. Now, what is the factor that makes it move faster, right? These are some things that you have to study. Now, what does the distance moved by an object in a unit time indicate? Distance moved by an object in unit time. Basically, what are we talking about? Let this be 10 meters. For example, you moved 10 meters, right? And for moving that 10 meters, to move that 10 meters, you took 20 seconds, right? You are literally walking very slowly and you took 20 seconds to cover this 10 meter. So, what does it significate? What is its significance? That what does it tell you? That this is the distance traveled by a body in this much time. So, these are some questions that we will be answering in this chapter. Let us start. Students, taking a very general example, you play all the time, right? With football or cricket, with any ball you play. So a moving object like a ball rolling on the ground slows down, right? For example, you are playing with a ball, with a football. If you kick it, after some time, after rolling for some time, it stops. It slows down basically. It is not that fast as compared to the time when you kicked it, right? It may change its direction of motion. For example, you are kicking a ball and it moved in this direction, right? It changed its course, or basically its direction of course. It is changing its direction completely, right? And the ball may slow down and also change its direction. Maybe both of things may happen, that the ball may slow down and change its direction, right? These are some random possibilities that may happen when you are playing with the ball, right? So what happens basically, you kick the ball, it moves forward, and it starts rolling, right? It rolls, that is how it moves. Or it may change its direction, change of direction, right? These are some possibilities that may happen, right? And if you are applying forces in this direction, can you imagine ball moving opposite to you? If you are kicking it this way, can the ball move back? No. You are kicking it in this direction, it is supposed to move in this direction. So this is not a possibility. These two possibilities may happen, that the ball will start moving, it may slow down after some time, it may change its course of direction, or maybe both can happen, right? It can also stop after some time. After slowing down, it may stop, right? The ball automatically stops moving if you are not continuously kicking it, right? So these are some possibilities that may happen. Now, why is this happening? Let us start with the first topic, force, a push or a pull. So what is this topic? Let us start with this topic. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. Let us take some examples. When you pick a ball, you are picking a ball, right? It is a kind of a pull. You are pulling it, right? Then opening. For example, you are opening a water bottle, right? Or opening something that has a lid. You have to pick it up, right? Then shutting. You shut the door of a fridge, right? And then kicking a football again. We can write ball. Then hitting any other surface. Then lifting, flicking, pushing any object, and pulling are often used to describe certain tasks, right? We often use these words in our daily lives. Each of these actions usually results in some kind of change in the state of motion of an object. What is the state of motion now? State of motion is the state. Basically, if an object is moving, then that is its state of motion. If you are trying to stop that object, right, you are trying to change its state of motion. Now consider a football. It is kept here. It is at rest. Right? Now this football being at rest is also its state of motion. Right? Here it is not moving, but this is also its state of motion. And when you kick it, it starts moving, it starts rolling and reaches here. So you gave this ball a motion. So when it was moving, that was another state of motion. Right? Now students, each of the actions can be grouped as a push or a pull or both. Let us see how. There are 3 examples. First one, a goalkeeper stopping the ball from going to the goal, right? Second is a hockey player dragging the ball with the stick, right? And then the third, a cricket player catching the ball, right? Now what is happening? This goalkeeper is pulling the ball towards him. Basically, it is stopping the ball, changing its direction and pulling it towards himself, right? The goalkeeper is saving a goal by doing this. Then a hockey player is flicking the ball along with the stick, right? It is trying to push it, right? This boy is pushing the ball. While the third one is a fielder stopping a ball. It is also changing its state of motion. The ball was moving and he stopped it. Now, how are these things possible? Basically, students, to do anything, to do any physical work, you require force. Without force, you cannot do anything. When I am picking up this pen, I am using some force, right? This pen, for picking this pen, I have to apply some force. That is how I am able to pick it. Otherwise, I will not be able to pick it. If I stop utilizing any force, this pen will fall down, right? So for every activity, we require some force, and that force is either a push or a pull or both, right? Now coming to magnets. What is magnet? A magnet attracts a piece of iron towards it. Any substance that attracts an iron piece towards it is known as magnets, right? In class 6th, you studied the chapter 13th, Fun with Magnets. You understood the course of action of magnets, right? Is attraction also a pull? You know that unlike poles, for example, you have 2 magnets and you have put unlike poles close to each other. So they will attract each other. So are they pulling each other? Yes. Magnets are trying to pull each other. Now what about repulsion between similar poles of 2 magnets? For example, you have put 2 magnets closer to each other with similar poles on the sides. Right? Now what will happen? They will repel each other. Repulsion will happen. They will push each other away. Is it a kind of a push or a pull? It is a push and attraction is a pull. Yes, so magnets also have some force inside them due to which they can pull another magnet or push another magnet according to the orientation of the poles. As you can see in this diagram as well, there is one magnet here and second magnet here with unlike poles towards each other, so they attract each other, right? While like poles repel each other. So this is also kind of a push or a pull, and hence we can say that magnets have some force, utilize some force in order to perform this activity, right? Now students, let us come to a conclusion. Force, what is force? In science, a push or a pull on an object is called a force. This is the basic definition. A push or a pull on an object is called force. Thus we can say that the motion imparted to objects was due to the action of a force. Let us take some example. This is a ball and you kicked it. So it started moving, it came into motion, right? So what do we say? We can say that the motion imparted on this ball is due to a force. And where did that force come from? When you kicked the ball, you provided it with some force due to which it came into motion, right? So every force can be categorized as a push or as a pull depending upon the type of force taking place, right? forces are due to an interaction. Basically, what we are saying here is forces can never take place without an interaction. There has to be some interaction between the objects. Let us start. There is a picture in front of you, picture 1 and picture 2, right? In picture 1, a man is standing beside a car, and there is a car which is at rest, right? It is not moving and it basically is not working. You have to take it to a mechanic, so you will have to push this car, right? Now, if you are not touching this car, can you push it without a touch? No. You need to touch this car in order to push it, right? So in the second picture, you see that the man is pushing this car and dragging it. Basically, the car is moving because this man is now pushing the car. So what did we learn? That until unless there was an interaction between both of them, the car did not move. So how was it able to move? When the man came in contact with the car was able to move. So here force has taken place due to contact, right? So these kinds of forces are known as contact forces, in which the contact is required, and we will be studying about these in detail as well. There is a separate topic. But here you just have to understand that without a contact, some forces cannot take place, right? Moving on to some more examples. In the first picture, basically, two girls are rotating around each other, holding hands, right? But they are basically wrestling. What happens in wrestling? The other person may be picking the other person up, right? One person may be picking other person or pushing other person. So in this case, they both are basically pushing or pulling each other. They both are doing pushing or pulling on each other. What is happening? They are interacting. They are in contact. If these girls are not in contact, they will not be able to push the another person, right? So interaction is necessary. Then in the second picture, what do you see? This is a kind of a game where you lock each other's hand, and you start revolving very fast, right? In Hindi, you call it as keekli. So in this, what are both the girls doing? Both are pulling each other towards them, right? You are holding hands, you are pulling the other person and rotating. So both of them are pulling each other, and because they are pulling with equal force, they are not falling. They are able to rotate, able to revolve. How is that happening? Because the force that both of them are applying on each other is equal. That is how they are equally pulling each other. So that is how they are not falling, right? So here it was pushing and here it was pulling, right? Now in the third case, this man is trying to move this bull towards the farm, right? But the bull is not ready. So this man is pulling the bull towards his side while the bull is pulling himself to the other. So each of them is pulling the other person, right? So here also the force is acting because of push or a pull. So coming to an inference, at least two objects must interact for a force to come into play. If there are no two objects, imagine there is a ball kept in a field. Can it move by itself? No, it will not be moving by itself. You will have to either kick it or pick it or push it. That is how it moves. So for any force to come into action, come into play, two objects must interact. This is the necessary condition. An interaction of an object with another object results in a force between the two objects. When one body interacts with another body, it results into a force between the two objects. And this is how force comes into action. The two bodies must interact. There must be an interaction between two bodies, and that is how it results in force between the two objects, right? Exploring forces. We are going to study some more details about forces. How do they act? What is happening? So let us start. Students, there is a picture A and a picture B, right? Now imagine you and your friend, basically Suraj and Ajay, are two friends and they have to move a box, right? So firstly Suraj started pushing the box, but he was not able to push it. Then Ajay came and started to push the box from the same direction, right? He also came alongside Suraj and started pushing the box, and eventually they were able to move the box. They were able to move the box, right? They worked together and they were able to move the box. Now taking example of two other students, Neeraj and Anil, right? Now they were also given the same responsibility. Anil started pushing the box from here, right? He started pushing the box in this direction. Seeing this, Anil started pushing. Now Neeraj saw that Anil needed help. Anil was not able to move the box. So he came in this direction and started pushing the box. Now he is pushing the box in this direction, in the opposite direction, right? You are pushing the box from here and Neeraj came and pushed the box from this side. So ultimately they were not able to move the box. Why did this happen? What is happening? Here, Suraj applied force in this direction and Ajay also applied force in this direction, right? And they were able to move the box. But when Neeraj came and applied the force in opposite direction, they were not able to move the box. Why did this happen? Because the forces were acting opposite to each other. For example, you are trying to pick a box, right? You picked it up with using your both hands. But imagine you are picking the box from this hand and pushing the box from the upper side with the help of the other hand. So this hand is applying the force in up direction and this hand is applying the force in down direction. So they will cancel each other. The box will not be lifted up. You will not be able to lift the box. So what do we understand? That forces acting in the same direction add up, basically. The two forces which are acting in the same direction, they add up. But when forces are acting opposite to each other, they cancel each other out if the magnitude is same. Let us see another example. This is a game, right? Where there are two teams. One of the team pulls the rope from this side and one of the team pulls the rope from this side. And this is the mark. This is basically the middle mark from which you have to make the other team cross, right? So this team is pulling the other team to this side and this team is pulling the rope from this side, right? Now whichever team applies maximum force will be able to pull the other team, because both of them are applying opposite forces, right? They are applying opposite forces. So only that team, for example team 1 and team 2, the force applied by team 1 is more than team 2. Let us take case 1 in which team 1 applies more force. Team 1 is more powerful than the team 2. The team 1 is applying more force. So the team 1 will win and they will be able to pull this team 2 towards themselves, right? This is the first case. Second case, when the team 2 applies more force than the team 1, which means that the team 2 is more powerful. So the team 2 will be able to pull the team 1 towards themselves and they will win. Third case scenario, that the force applied by team 2 is equal to the force applied by team 1. Then they will never be able to pull any team towards themselves, right? No one will win. So what are we studying here? We are studying that when forces are applied in opposite directions, the force that has larger magnitude is the net force, basically, right? Let us come to an inference. Forces applied on an object in the same direction add to one another. We have already learnt that. If the two forces act in the opposite directions of an object, the net force acting on the object is the difference between the two forces. Basically, let us come to this example. There were two forces acting on the rope. This is the rope, right? Force 1 is applied by team 1 and force 2 is applied by team 2. Taking the first case scenario to be true, that team 1 applies more force than team 2, the net force acting on the rope will be equal to force applied by team 1 minus the force applied by team 2, because team 1 is applying more force. So the net force will be the difference of both the forces, right? And we subtract the smaller force from the larger force to get the value of the net force, right? For example, there is a pen, right? I am trying to pull the pen from this side and my friend is trying to pull the pen from this side, right? Now, the net force will be the difference between the two forces. If I am stronger and apply more force, then I will be able to pull the pen from my friend, and the net force acting will be the difference of the force applied by me and the force applied by my friend. Alright, simple. So we have to basically understand the concept of forces acting opposite to each other, right? So this was the second topic of your chapter. Third topic, sorry. A force could be larger or smaller than the other or equal to each other. As I told you, in this case, force 1 may be larger, force 2 may be larger, or they both may be equal to one another, right? Now, the strength of a force is usually expressed by its magnitude. Strength is expressed with the help of magnitude. In general, more than one force may be acting on an object, right? However, the effect on the object is due to the net force acting on it. Basically, as we saw in the case of rope, there were two forces acting. The team 1 applying the force and team 2 applying the force. The net force was due to the team 1, which had the larger magnitude, and the net force was the difference of the forces of team 1 and team 2. The net force will be team 1's force minus team 2 force, right? And the effect will be due to this difference only. We will not be taking in account the personal forces. The net force, the difference will be the net force acting on the rope. The rope will be dragged to either side due to the net force only, right? Because that is the force that has not been cancelled. For example, the force applied by team 1 was 10 units, right? And the force applied by team 2 was 8 units, right? So the team 1's force is more than team 2nd force. The net force will be equal to team 1's force minus team 2's force, that is equal to 10 minus 8 units. That will be 2 units. So if we take this example here, the net force is 2 units and basically the difference between the forces of both the teams, and the magnitude of smaller force is subtracted from the magnitude of larger force, and the net force comes out to be the difference, which is 2 units, right? A force can change the state of motion, as we discussed in the first lecture as well, that a force can easily change the state of the motion of an object, right? So let us start with the topic. There is a picture in front of you in which there is a kid and there is a ball. The ball is at rest, right? It is not moving, and when the boy kicks the ball, it starts moving, right? And it comes into motion, right? So here the boy was applying the force and it was changing its state of motion. Firstly, it was at rest. It is also a state of motion. And when he kicked, when he applied the force, the ball came into motion. This is another state of motion, right? So what are we saying here? Basically, a force can change the state of motion of an object. Now see, A ball at rest begins to move when a force is applied on it. For example, this was a ball and you pushed it with your hand, right? The ball was at rest. But when you applied force and you pushed it, the ball started moving, right? This is very common. Now another example of a penalty kick, right? In the penalty kick, the ball is at rest, right? We all know what penalty kick is. It is at rest and this player is about to kick the ball, right? Now when he kicks the ball will move towards the goal, right? Now this ball may score the goal or reach here, right? Or first case scenario is that the goal may be scored, right? The second is that the goalkeeper may pull the ball towards himself or may stop the ball. So firstly, the ball was at rest, the footballer kicked the ball and it came into motion, right? When the ball reached the goalkeeper stopped the ball, right? Again changing its state of motion and bringing it at rest, right? Third case may be that the goalkeeper may deflect the ball. He may change the direction of the ball, right? He may change the direction of the coming ball. For example, the ball is coming this way and I deflected this way. I have protected my goal, but the ball's state of motion has changed, right? I have changed the direction of the ball. So these are some scenarios that may take place during a penalty kick. So what is force doing here? Force is changing the state of motion of this ball. First of all, it was at rest, then it came into motion, then it was either stopped by the goal or by the goalkeeper, or he may have deflected the ball and the direction of the ball was changed, right? So all of this is happening because of force, and the force is changing the state of motion of the ball. So a force applied on an object may change its speed as well. For example, there is a moving ball which is already in motion. This is the ball and you kick it very hard. It will move faster, right? It will move at a good speed, at a greater speed. So the force applied on an object may change its speed as well, right? If the force applied on an object is in the direction of its motion, the speed of the object increases. For example, your friend is cycling, right? Your friend is cycling and you push him from backwards. The speed of the cycle will increase. Basically, this is the cycle and here your friend is sitting on it and he is moving in this direction. Now you come and you push the cycle from this direction only and you apply force. So the speed will increase because the forces are applied in the same direction, right? Now taking another example, if the force is applied in the direction opposite to the direction of motion, then it results in the decrease in the speed of the object. For example, you are moving on a cycle, right? You are going in this direction. Your friend comes and he tries to stop you. He applies force in the opposite direction, right? So this will decrease the speed of your cycle, right? Because you are moving in certain direction and your friend comes and stands in front of it and applies force in opposite direction. So this will decrease the speed of your cycle, right? So this is the effect on speed whenever a force is applied. If the force is applied in the same direction, for example, I was cycling and my friend comes and pushed me in the same direction, my speed will increase. But if I am moving and my friend comes in front of me and applies opposite force, my speed will decrease, right? So this is the effect on speed depending on the direction of forces, right? Now there is an example from childhood some children play this game. There is a tire and there is a stick, right? To keep the tire moving, you have to continuously hit the tire, right, with the help of the stick. So what are you doing basically? With the help of this stick, you are applying a force in the same direction, isn't it? The tire is moving in this direction and you are applying force in this direction so that the tire's speed increases, right? So that is why basically I now understand why the speed of the tire increases whenever it is pushed, because force affects speed, right? It affects speed. When applied in the same direction, it increases the speed, and if in opposite direction it is applied, it decreases the speed, right? This is what we are talking about. Now there is another example. For example, there was a ball at rest. First of all, the ball was here, it was at rest, then you pushed it and came into motion, right? Here is state of motion is being changed. State of motion is changing, right? Now in the second case, a ball is in motion, is set in motion by pushing along in the right, the direction of the motion of the ball after it strikes the ruler in its path. The ball was moving, and it hit the ruler. You have held a scale in front of the ball, so the ball reflects in another direction, right? Here the scale changed the direction of motion of the ball, right? Basically you applied some force with the help of this ruler and the change happened in the direction of the ball, right? Now in case of volleyball, what happens in volleyball? One player strikes the ball, it comes into another court, the other person raises the ball and another one smashes the ball. So there are a number of forces taking place and all of them are basically pushing the ball to the other side. So here we majorly see pushing, picking, right? No pulling is seen in volleyball. You just have to throw the ball to the other court by smashing it or by hitting it, right? So here also force is changing the direction of the ball, and again the ball was here, she pushed it there, now they are pushing it back, now this player will push this ball back, this one will push it back. So here the direction of the ball is changed again and again by applying force on it, right? So volleyball shows clearly that the force can change direction of motion of an object, right? Now cricket is a very typical example. The ball comes towards the bat of the player strikes the ball by applying some force, and the ball moves in a completely different direction. So here also force is changing the direction of motion of the ball, right? As simple as that. The bat is basically changing the direction of moving ball because you are applying some force, right? What is the inference that we draw? A change in either the speed of an object or its direction of motion, or both, is described as change in the state of motion. Whenever we change the speed of an object or the direction of an object or both, we call it as the change in its state of motion. Thus a force may bring a change in the state of motion of an object, right? The force can increase the speed, it can change the direction, it can decrease the speed. So the force brings the change in the state of motion of an object, right? Now the state of motion of an object is described by its speed and the direction of motion, right? For example, an object is moving in right direction, in east direction, with the speed of 10 units. So this is its state of motion. the state of rest is considered to be the state of zero speed. It is also a state of motion. That is what I was telling. When a body is at rest, it is also a state of motion, and we call it as the state of zero speed. An object may be at rest or in motion, both are its state of motion. Right? So in this lecture we studied about state of motion and the effects of force on the state of motion of an object. Right? Force can change the shape of an object. Till now we saw that the force can change the state of motion of an object, right? It was changing the speed, the direction of an object. Now we have to see that force can not only change the speed and direction, but the shape of an object as well. We will be looking at some examples where force applied changes the shape of an object. Let's see. First example is a lump of dough on a plate, pressing it down with your hands. Basically, if you belong to an Indian family, you know atta. Atta, when you prepare chapati from an atta, you prepare dough, right? Dough matlab ki, what does dough mean? Dough means जो लोई होती है आटे की, वो dough होता है, जो मढ़ा हुआ आटा होता है, that is dough. So you can easily push your hand inside the dough and the shape of the dough will change, right? You are basically applying some force and the dough changes its shape. So here force is changing the shape of dough. So yes, force can change the shape of an object. Second example, spring fixed to the seat of a bicycle. There is a bicycle and there is a spring under the seat of a bicycle. But when you sit on the bicycle, by sitting on the seat of a bicycle, the spring which was elongated earlier compresses, right? It becomes smaller in size, right? So yes, it is changing its shape which was earlier elongated. Now it is compressed. So here also, in the case of a bicycle's spring, the force is changing the shape of an object. Thirdly, a rubber band suspended from a hook or nail fixed on a wall. There is a rubber band, there is a nail on the wall, and you have suspended a rubber band on the nail, right? Now when you apply some force, basically you hang a hanger from its end. You have now put a hanger on the bottom. Now the rubber band will expand, right? It will change its shape. So when you applied some force on the bottom of the rubber band hanging on a nail, it expanded, right? It stretched due to the force applied. So here also, the force of the object hanged from the rubber band is changing the shape of the rubber band, right? It basically is expanding the rubber band. So yes, the shape of the rubber band is changing. Fourth example, a plastic or metal scale placed between two bricks. You have two bricks, brick 1 and brick 2. You have placed a scale on the top of both bricks, right? These are the bricks, brick, brick, and this is the scale, right? But what you do is, by putting a weight at the center of the scale, you have now put a weight on the scale. Now the scale will somehow bend, right? The scale is now not straight, it has bended, it is bent now. So what does this mean? That the force that was applied due to the brick that was kept on the scale has changed the shape of the scale, right? So in all these examples, we can understand that force can change the shape of an object, right? Now let us see effects of motion. It may make an object move from rest, on motion we are going to say, right? May change the speed of an object if it is moving, right? Effects of force here. Basically, we are studying about the effects of force. It may make an object move from rest. We have studied that. It may change the speed of an object if it is moving. It may change the direction of motion, right? And then it may bring a change in the shape of an object. As we just saw the 4 examples, force can change the shape of an object as well, and may cause some or all of these effects. There may be first 2 happening, second 2 happening, or all of these happening. there are different cases where different kinds of effects are seen. Effects of force are seen, right? So these are the effects of force on any object, right? Thank you for your attention, students.